Hello everyone, it's me again. I'm so glad to meet you guys again in the third lesson in the topic of Cartesian plane. In the previous lesson, we have learned a lot of things related to lines, how to construct the equations for lines on Cartesian plane, and we will also examine about a line's gradient, which means which is a parameter, a measurement of how steep a line is. So today we will continue with more interesting features about lines. Okay, so buckle up. Let's begin the lesson. In the first section of the lesson today, we are gonna learn about the midpoint formula, a formula that will be very handy in the future problems. Let me give an aligned segment AB. The midpoint AB has coordinates equal to the averages of corresponding coordinates of A and B. So let me give 2 points A and B. So we have a line segment AB as shown on the diagram. And the midpoint of the AB is the point that divides AB into exactly two equal halves. And because the midpoint lies somewhere in the middle of the 2 points AB, so in instinctively, it has the coordinates equal the averages of the corresponding coordinates of AB. That is, the x-coordinate of the x-coordinate of the midpoint is equal to the average of the x-coordinates of A and B. So you can see that in the formula, the x-coordinate of I is equal to average of XA and XB. And similarly, the y-coordinate of I is equal to the average of y-coordinate of A and B. So this is the midpoint formula, a simple formula that helps us to determine the midpoint's coordinates. So let's come to an example to see how the formula works. A 1, 3 and B 5 minus 1 are given. Find the midpoint of AB. So you can see on the Cartesian plane the point A and point B. If you use the geometrical method, the visual method, you can find the midpoint I has the coordinates 3 and 1. If you look at the Cartesian plane and use your visual power, you can determine the point I is equal to 3 and 1. And now let's check the midpoint formula to see whether the formula gives the same answer. So we take the average of the x of A and x of B. So we take 1, the x of A, plus 5, the x of B, and then divided by 2. 1 plus 5 divided by B. Next, we find the average of the y-coordinates of A and B. 3 here, plus -1 here, all divided by 2. And if we simplify the values, we can have the x-coordinate of I is 3 and the y-coordinates of I is 1. So the formula agrees with what we can see on the Cartesian plane. So it works and the formula is confirmed. In the next session, we are gonna learn about perpendicular bisector. The perpendicular bisector of a line segment AB is the line perpendicular to AB, which passes through its midpoint. So let me give a segment AB like this. This is the perpendicular bisector of AB. It is perpendicular to AB and it passes through the midpoint of AB. In the figure, D is the perpendicular to AB. In the notation language, we will write D is perpendicular to AB like this, and D intersects AB in I, and IA is equal to IB. Please notice that the perpendicular bisector has a lot of interesting features. Two of them are listed below. Every point on AB's perpendicular bisector is equidistant from A and B. Equidistant means having the same distances. It means that let's take any point on the line D. So the distance from that point to A is equal to the distance from that point to B. So you can take any point on D. So, and the distance from that point to A is always equal to the distance from that point to B. And the perpendicular bisector divides the plane into two halves. The first half is points that are closer to A, like this. And the second half is points that are closer to B. Now let's have a look at an example here. Given A for -3 and B -2, 7, find the equation of the perpendicular bisector of AB. Now we know that the perpendicular bisector passes through the midpoint of the line segment. So first we need to find the coordinates of the midpoint M of AB. That's why we have the first section earlier. Applying the midpoint formula, we have the coordinates of M should be 4 plus -2 divided by 2, and -3 plus 7 divided by 2. The x coordinate is 1 and the y coordinate is 2. So D passes through the point 1, 2. Now we need to deal with the condition that D should be perpendicular to AB. In order to solve the conditions related to angles, we should rely on the gradient. So first we need to find the gradient of D. But before that, in order to find the gradient of D, we must first determine the gradient of AB. Applying the gradient formula, we have the gradient of AB is -3 over -5 over 3. And as you remember in the previous lesson, or maybe the lesson even before that, the two lines will be perpendicular to each other if the gradients of them have the product equal -1. So now we have the gradient of AB is -5 over 3. So in order for D to be perpendicular to AB, its gradient must be the -1 divided by -5 over 3. -1 divided by -5 over 3, and that should be 3 over 5. Now we have the gradient of the line D. We also know that D passes through the point 1, 2. Now we can easily find the equation for the line D. That skill is taught in the previous lesson. If you forget it, just come back to the previous lesson, the UM8 math number 16, and then come back to this video. The equation of D is, now I will first apply the point gradient form of the equation. Y minus 2 equals 3 over 5 x minus 1, and by some transformations we obtain the form 3x minus 5y equals -7, and this is the general form, which is most preferred, I believe. So after some steps, first we find the midpoint of AB. The second step is to find the gradient of D via finding the gradient of the line segment AB. And the third step is to apply the point gradient formula to determine the equation for the line D. If you want to put it in general form, just use some basic algebraic transformation and you'll get to that. Do you remember the procedure? Alright, now comes the last part of the lesson. The intersection of lines. We begin with the intersection of two different lines because three lines can have or have no intersection at all. So we will use the most basic and the general case in which we have two different lines. So intersection of two different lines is a point that belongs simultaneously to both lines. We have D1, D2, so the intersection E should be in this position. And because I belongs to both lines, it must satisfy both lines equations. So it must satisfy both ax plus by equals c and a prime x plus b prime y equals c prime. Now let's come to an example. Find the intersection of d1 x minus y equals 3 and d2 2x minus 3y equals 4. The x and y coordinate of the point I must satisfy x minus y equals 3 and 2x minus 3y equals 4. And from the first equation, we will imply that y is equal to x minus 3. We will substitute this value to the second equation to have 2x minus 3, not y anymore, but x minus 3 here. And by simple equation solving skills, you will obtain the value x equals 5 and y equals 2. So 5, 2 is the coordinates of the intersection I of D1 and D2. So that's how we can find the coordinates of the intersection of two lines when we are given the equations of both lines. Okay, and this is also the end of the lesson. I think it is quick but very informative. Now um at home, I hope you will spend more time review the lesson and learn better three key points of the lesson. The first is the midpoint formula, the tool that helps us quickly determine the coordinates of the midpoint of a line segment. The second is the skill that helps us to find the perpendicular bisector of a line segment. And the third is how to find the intersection of two different lines. And at home, I will encourage you to go to the internet, read books, or any resources that you can find and learn more about the Cartesian plane. Okay, I think that's enough for today's lesson. And get ready for the next chapter. Not the next chapter yet. The next lesson is gonna be a big revision. So there will be some quizzes. I hope you get ready for that. Okay. And thank you for attending the lesson and see you next week with another Math UMS lesson. Bye bye.